Welcome to this video. So in this video we are going to discuss about simple RAG. Here RAG stands for Retrieval Augmented Generation. Why we need RAG first of all? Okay. We all know like large language models or generative AI models. So they will answer your questions based upon the knowledge it has been trained on. So for example, if you type anything on ChatGPT, it will answer your question. Either it may be ChatGPT or Claude or Gemini models. So how it can answer the questions? So these models are trained about a vast amount of data, especially publicly available data, and then they feed into it, and then they will train those models, and based upon that only we are getting the answers. So now each model has their own cutoff date. For example, if you take the ChatGPT, it has its own cutoff date. So until that date, whatever the knowledge available or provided, it will be trained upon that particular data. That will be the cutoff date. And after that, whatever you ask related to a recent event, it can't be able to answer. Same goes to like, for example, if your company or your business has its own internal data, it can't be able to answer because that is not publicly available. So if it's not publicly available and it is internal data, it doesn't have any access to it, so it can't be able to answer based upon that particular documents. So that's why RAG comes into play. So there are two techniques where we can train or give large language models the internal source or the actual source you want to answer from that one. So one is fine tuning, where you can fine tune the large language model based upon your own data source, and other one is retrieval augmented generation. So here fine tuning is a bit of cost expensive as well as process heavy, and it requires a lot of training, and as well as it's a big process. Like you need to train the large language model based upon your own internal data, and then it will answer the questions, and that too. So that is for example, if you train a set of documents or set of data, and then you ask questions, it will answer. But after that training, whatever you have, you cannot answer. It's the same as the previously what the issue we have in large language models. So now, in order to have the knowledge base of whatever you have in your business or in internal data sources, we go for retrieval augmented generation. Okay, so retrieval augmented generation is a process where you give the context. Like for example, the large language models or generative AI models, generally they will answer the question based upon the context. For example, if you ask a question, it will get the context either from its internal trained data, or the context what you provide. So in general, or in the basic fundamental thing what large language models can do is that it can generate text. That's it. So it will generate text. So how it will generate text? It will generate text based upon the prompt you give, and then it will continue generation. And that prompt, if you add the context, so based upon that, it will give you the answer. So that is a basic premise how actually the large language model works. So now, in order to answer questions specifically upon a given context, you need to have a technique. That technique is called retrieval augmented generation. So what and how it works? So now, if you see in the diagram, so there is a user. So the user asks the query. Like for example, he wanted to get the typical answer from a given source. Let us assume the given source is the latest financial record or financial document, or last year or Q1 financial status of its own company. Definitely the large language models, it doesn't have the information. So what he has to do is that you need to feed the context to the large language model along with the query, such that it will answer from that context relevant to the query, and then give the answer. So now how it has been accomplished. So in general, what we can do is that the flow is like this. Like the process is step by step, where I will explain it now. The user asks the query, so give me the latest or give me the Q4 results summary. Okay, so sorry, Q2 results summary of this particular year. So it is passed to the large language model. So now before that, what we need to have is that the database. So here we are specifying the database in the sense of vector database. So what is vector database? So that is a different topic. Now I will simply explain. For example, your company have the financial documents. Okay, so this is the document database. Now we are feeding the document database documents. Either it may be a PDF document or it may be a Excel, whatever may be. So those documents are fed into LLM. So those when we feed into the LLM will convert those documents. There is a big process before feeding it to the, like, we need to parse the document, we need to chunk it, and then only we can able to feed it. We cannot feed as it is. So these steps I will explain in later. But so obviously we are going to do the process step by step. Like if it is a PDF or Excel or Word, we need to parse the document and then get out the chunks, like after parsing, and then that chunks will be passed to a embedding encoder model, and then that model will convert those text chunks into vector embeddings. The vector embeddings are a specialized data model or data where the large language model can understand. So each chunk will be converted into vectors, and then those vectors have been stored into the vector database with indexing. Okay, so now when the user asks the query, that query will be converted into vector embeddings. Now we have the query vector embedding, and then it will search, semantically search the relevant document chunks in the document database, that is, sorry, in the vector database, and then those chunks along with this vector embedded query will be passed into the augmentation phase, where these documents along with the query will be passed with the to the LLM, so that it will augment everything, and then finally it will generate the answer from those documents based upon the given user query. So then you get the answer. So it seems like, okay, so we are giving the context, whatever is required for the LLM to generate the answer, but you may say, like, we will get the most relevant or accurate answer, but generally it is not the case, because even retail augmented generation fails in most of the cases. Why? Because there are a lot of steps involved, and if these steps are perfect, then only we can able to get the final answer or more accurate answer. So now so there are different stages where we can tune such that we will get most accurate answers, and finally we can even evaluate the final answer, and then we can deploy those system in the production.